Welcome to Section 1.3, Introducing Irrational Numbers. Lesson objectives: understand irrational numbers and how they fill the number line. Use rational numbers to locate irrational numbers approximately on the number line. Vocabulary for this lesson: irrational numbers and approximate or approximate. So let's take a moment to make sure we understand irrational numbers on the number line. Consider a small portion of the number line close to 0. If 1/4 is close to 0, then 1/8 is even closer to 0. In the same way, 1/16 is closer to 0 than 1/8. If you carry on in a similar manner, you can see that there are infinitely many rational numbers clustering very close to 0. In fact, this phenomenon appears at every other point on the number line. However, there are holes in the number line. There are numbers which are on the number line, but they are not rational numbers. Remember, that means they can't be written as a fraction with an integer numerator and an integer denominator. One such example is the square root of 2, because it cannot be written as m over n, where m and n are both integers. So I'd like you to try this hands-on activity. You'll need paper, a ruler, and scissors. Take a moment to get those things now. You'll also need a partner. Find a partner. Someone sitting near to you is a good idea. And the objective is to find the value of the square root of 2 using a square. So draw a square that has a length of 2 inches, so a side length of 2 inches, on a piece of paper. Then cut out the square. Find the area of the square. Fold the 4 vertices of square A towards the center to form square B, as shown below. State how the areas of square A and square B are related. State the area of square B. How can you represent the length of a side of square B? Using your answer in step 4 and a calculator, find the length of a side of square B with a calculator. Round your answer to 2 decimal places. That would be the hundredths place. And now place an edge of square B alongside your ruler to measure its length. Explain why the reading from the ruler is different from the answer in step 5. The readings from the calculator and from the ruler give approximate values of the square root of 2. The length of a side of square B. You may also regard the marking of the square root of 2 on the ruler as a point on the right side of the number line, right? Meaning to the right of 0. Next, we have a happy child who wants to tell us all non-zero multiples of the square root of 2, such as 2 times the square root of 2, 3 times the square root of 2, 4 times the square root of 2, and so on, are also not rational numbers. Thank you. In other words, the positive side of the number line has many holes that do not contain rational numbers. There are also similar holes on the negative side of the number line. So the entire number line has many holes. To make a complete number line, you have to fill in the number line with numbers, such as the square root of 2 and many others. These numbers are called irrational numbers. An irrational number cannot be expressed as a ratio of 2 integers. So it has a decimal value which does not terminate or repeat. As this girl points out, so the negative of the square root of 2 is a negative irrational number. Why, thank you, girl on the bottom of the page. Check out the math note here on the right-hand side. The term rational number means that the number can be expressed as a ratio of two integers. So the term irrational number means that the number cannot be expressed as a ratio of two integers. Oh, and I like this caution statement here. The negative square root of 2 is different from the square root of negative 2.